Good morning, everybody. Let's start the presentation. All the other people that will come, hopefully will be able to join. Let me introduce myself briefly. I'm working at Dell as an AI CTO all over EMEA. So I try to make kind of a landscape of the EMEA projects that we do, how we do it scalable. And let me show you our approach, how we do the liquid-cooled and non-liquid-cooled AI projects. Mainly, I'm responsible for the AI, so I cannot say anything about the virtualization and databases and others. So the focus is today the AI. How we see currently the customer's buying process is a bit different. So on the left side, you can see that many times they want to start the conversation with testing the waters. That means that they just want to get some glimpse, some ideas, some feelings about the project, and they say that I have 1 megawatt of power, or I have 1 million euros, or I have this and that amount of space. What can you do with that? What can fit into the power budget, into the financial budget, into the floor space? How can we somehow estimate the amount of equipment and the amount of manpower that we need? And many times we see that we have around 10 to 30 minutes to answer these questions, and this is very good. I mean, if we go the old way that we need to make the quotation, make the complete gearing around this set of requirements, then we cannot test the business ideas. And nowadays, more and more customers are thinking to evaluate their ideas, and they just want to fail very fast. So try fast, fail fast, I mean in 10 minutes or 30 minutes, and evaluate that idea. And we can help in that because many times that leads to the next idea, next idea, next idea. And then after the 9th idea, the 10th, hopefully will be a good idea. So testing waters, is the first phase which we face. The second one is kind of a beauty contest. The beauty contest means that we are not born to be AI developers or AI infrastructure makers. The AI changes a lot from day to day. So it's like the dog's life. It's a 7 times multiplier. Whatever happened 1 month ago, it feels that it happened half a year ago because so many things has happened in the past 1 month, even in the 1 month. So that means that we learn continuously, and maybe the set of requirements are not the final set of requirements. So please allow yourself to be not so accurate in this beauty contest phase, and enable and allow additional ideas to come. And the next 2 phases, the RFP and best and final offer, as like in other projects. So we can accommodate that, and you are used to that. However, the first 2 phases are important. So if you have a business idea, then let it test it, and we can help you in testing it, maybe failing it, because failing a business idea is not a bad thing when it's on the table and in the Excel sheets yet. Let me raise your attention that many projects can fail on the business side because the GP as a service, for example, at CSPs or at an enterprise scale, has a lot of risks, a lot of operational risks, procurement risks, and many others. We are here to help you on this journey and help you to identify those risks and fill the gaps most probably and hopefully. Regarding the beauty contest, again, just iterating, there are a lot of ideas that are continuously evolving around flexibility, around security, around operability, and we need to evaluate all these aspects. So when we want to buy a system, a secure, scalable, fast system, then we would like to set some goals for ourselves and avoid some things because that would be really bad if we would have a non-operational IT equipment, set of IT equipment. So we created this buying compass, which means that, just 2 slides, which means that I would like to show you some examples which are the targets or which can be the targets for you, and what are the hidden dragon layers, the hidden gaps that you may want to avoid. So treasures and dragon layers. Let's see what are the treasures that in a generic AI project we would like to achieve or get. So we would like to have an outstanding perceived value. So at the end of the day, we want a business value from the AI solution that we manufacture or we assemble, including operationally scalable. We would like to put there the organization as well, and so on and so forth. We would like to have an end-to-end solution, right? Because we don't want a partial solution. We don't only want to buy the GPU servers, because what happens with the software? What happens with the operation? What happens with the data? What happens with feeding the data, enhancing the model, enhancing the data? What happens with the trainings? So there are a lot of aspects in this end-to-end project. The next one is the lead time. So if we imagine something today, we would like to get it maximum when. So let me ask a question. If you had a business idea, who would vote that they would want a complete end-to-end system within 6 months? So who would say that you would need a solution within 6 months? Okay, nobody. 12 months? Would need it in 12 months, okay, 1 year. More than 1 year? Okay, so with a few hands, I think that the 1 year was the winner, and this is what we see currently, that most of the customers want to have the business idea implemented within 6 months to 1 year. This is the most. Sometimes we go to 1.5 years. However, if it spans over 1 year, then the whole business idea would be risky. So we see that the 12 months is more or less the maximum-ish. However, on the other side, the GPU lead time, the disk lead time, the memory lead time, the optics transceiver lead time, switch lead time is really, really long in many cases. So it's sometimes it's 6 months, sometimes it's maybe more. So it's really a hard challenge to schedule everything into one line and provide this 12 months deadline for the project. We would like to have a low dead on arrival rate. Dead on arrival means that when the product comes, then does it work or not? And when we are talking about virtualization, database servers, and others, it's very, very normal. Then when we receive the goods, then it's working. Why not? Why not? But the GPUs are very sensitive to the shocks, to the vibration while the transportation. So we need to make sure that everything works in advance before it goes to your data center. And that's why we introduced many measures like the rack integration in our facilities in Cork, for example, where we pre-test everything, we assemble everything, and so on and so forth. And at the end of the day, you want an affordable price. So I think that's self-understandable. When we see the complete project, and you see in the lower right corner, if you can see it from the back, a mock-up that we have the data center shelter, we have the server storage networking, we have the cooling, the power, the organization, the services, additional added value, then you can imagine that is a huge project even for a small system. And we would like to provide an end-to-end solution for you, including sometimes the data center, because that can be the most crucial part of the solution. When we see how the enterprises, the cloud service providers, and specific cloud service providers think about the components, we see many times that the logistics that we provide is a very good point or very good added value from Dell to them, because the schedule is one of the most important things. The schedule, the logistics schedule, because if the goods are there staying for, let's say, 6 months in your data center without actually doing any production, then you lose a lot of money. So the depreciation can be up to 20% of the value of the goods, which is huge. So we aim to schedule the operational time of the GPUs, of the control plane, of the cooling and power and everything to that time when the GPU would be there, and minimize the additional time to put it into operation. Also, we are many times talking about tenant softwares, what will be run on the GPU nodes, on the worker nodes, for example. Would it be Red Hat? Would it be Canonical? Would it be another distribution? Or we are talking about the control plane in a few slides, so how to make it flexible. So the software environment is not negligible. I would like to raise your attention that the software will be very, very important to orchestrate the whole environment. And if the software does not work, then you cannot put the GPUs properly into operation, and you cannot repurpose the GPU nodes. Many times we see, let's say 95% of the cases we see, that the GPU nodes are not a static, do not have a static configuration. They change over time from month to month. And if you want to really increase the utilization beyond 90%, then you need a proper software orchestration layer for that. What are the dragon layers? What do we want to avoid? Bad quality, for example, high dead on arrival rate, as I mentioned. So for that, we need to make some measures. Bad logistics, for example, sometimes we hear that logistic partners just show up and there's nobody who could receive a rack with multiple millions of euros, and they are just standing outside, maybe in the rain. So that's not good. Bad timing, I will talk about the timing a bit later. Bad design together with bad cooperation. We see many times that the design of the power, design of the cooling, design of the data center is not coherent. And by the way, the current rack weights are around 1 ton, 1 metric ton, so 1,000 kilograms. The 2026, so this year ends, weight will be around 1.5 ton, so 1,500, 1,600 kilograms. Next year, 2027, we foresee around 3 to 4 metric ton racks. So just imagine one rack, okay, it will be 120 centimeter wide by 120 centimeter deep, and that will be 4,000 kilograms. So how does the data center accommodate this? And how, just a simple question, I mean a simple challenge, how do you push this rack into the data center? How can you assure that this rack will not go over a ramp or over a barrier or threshold which is higher than 3 to 5 centimeters? So we need to prepare our data centers, our logistics, our storage environment in order to accommodate these physical limitations or challenges, to put in another way. So we need to cooperate with other vendors, with the data center facility, with many other providers in order to provide a seamless integration of the goods when we are there and we need to wheel it in. One of the worst layer, dragon layer, that we want to avoid is the bad timing. I mentioned that the depreciation is around, let's say, 3 to 4% per month that you lose if your deployment time is longer. However, you always need to take into account the NVIDIA or AMD schedule. So mainly we are talking about these two GPU vendors. For example, if somebody wants to go for the market and sell the GPUs as a GPU as a service, then they might need the newest version or maybe the newest -1 version, and you need to take into account the hourly rate of the GPUs. And if your let's say your B200 or H200 GPU is old versus the newest GPU, for example, versus the GB300s or B300 or Vera Rubin later this year, then it might be that the whole business case will not stand. So maybe your business case in the beginning was good. However, because of the project delays, and even 6 months delay is a huge delay, the hourly rate that you can get from your customers is very, very low, and your customers will not get to you, and they will say that, okay, that 6 month contract was enough. I don't want to lengthen it and make it longer. So you will not get the hourly rate, and the whole business case will not stand. So that's why the business revenues and the business schedule is very, very important in making such systems. So don't underestimate, please, the cabling lead time, the transceiver lead time, the switch lead time, the GPU lead time, and the cooling lead times, because sometimes we experience that, for example, the chillers have long lead time. The generators, by the way, the gas generators have extremely long lead time. Middle voltage transformers have long lead time. So everything is on long lead time. You need to be very wise with the schedule. If we want to achieve the right business outcomes, then we need to take into account or pay attention to at least 9 factors. So as you see here, financials, schedules, data center facility, including power and cooling, the quality of the whole environment, because a bad quality product is really hard to maintain and hard to sell. Organization, who will support and maintain the whole environment. Data flow, data quality, what is the data that we are building on. Maintenance, security, and flexibility. Flexibility can mean scalability as well, but it's a bit more. So it's 9 factors, and I would like to see, and I would like to check and recheck our solutions, how much of these requirements does it have. Before going into that, I would like to raise your attention that currently most of the customers are looking for model augmentation. So this is RAG, retrieval augmented generation, and for distillation or fine-tuning. So the distillation is a specific case of fine-tuning. This is 90% of the cases. The other 10% is the training and the other part, I mean the inferencing, where we don't use any augmentation, just a plain inferencing. Okay, so 90% is within the dashed area, retrieval augmented generation and distillation. Why is it important? Because for the retrieval augmented generation, we need some data, external or internal data, either within databases or within some documents, PDF documents, PPTs, PDF, Word documents, whatever. And those data needs to be crunched and parsed. We call it parsing the data, put into a vector database, and from a vector database, we can feed the actual models. Around the security, we need to make a security wrapper around the model augmentation in order to not to feed with bad data. I mean, first we need to a bit clean the data, sanitize the data, and when we have an external request, then we need to evaluate whether the external request is valid or they just want to breach the system. Okay, there is a lot of additional things that we need to pay attention to. When we want to build a system like this, we always go back to this model. So in the bottom, we have some data center facility. Let it be a brick and mortar data center or a modular data center. Nowadays, the modular data centers are very popular because the lead time, I mean, the deployment time is between 6 months for the smallest ones. I don't want you to remember the 6 months because it's rather 9 to 12 months as a minimum. And those can be located anywhere where the power is. So a very important topic, either you bring the data center to your data, or you bring the data to the data center where the power is. So sometimes we see the customers to install the modular data centers to locations where there is a power, because to bring the fiber and bring the data to those locations is much easier than developing an existing site with multiple megawatts of additional power. So decommissioned radio stations, decommissioned telco stations, and many others, or power plants where the power is there and the grid is ready to receive the modular data center. On top of that, we have these traditional set of equipment. By the way, let me share with you an interesting piece of fact, that the GPU server alone is around only half of the project costs. All the other 50% is about the software, about the maintenance, data center, security, and many others. So when you do the budgeting and you just say that, okay, that should be 3 million in GPU servers, be brave and add the other 3 million for the additional costs that you may need. Okay, so on top of these hardware and software architectures, you will need a control plane, a multi-tenant control plane that is that enables you to receive the external requests, and the external customers that I call tenants can log in onto this customer service portal or control plane portal, and then they can provision there the software environment, the storage. I want one more GPU, I want one more core, I want to archive my data, and so on and so forth. So it would automate everything. If you can comfort your customers, either let it be internal customers, so if we are talking about an enterprise-grade customer, and we are talking about departments, or an agency, a public administration agency, or we are talking about a CSP, the more we comfort our customers, the higher the utilization rate will be. Why is it important? Going back to the business, if the utilization rate is low, then it will not finance our project. If the utilization rate is high, then we will be on a positive margin and we will be happy at the end of the year. So we are working on, and you should work on, increasing the utilization on the GPUs, comfort the customer, make everything automated. Don't do very labor-intensive operations. Automate everything if you can. Make automated security, make automated logging, and so on and so forth. So the automation is a key for the scalability, to comfort the customers in order to give them a Mercedes feeling in which your utilization will be high and the business revenue will be high. Yep. Yeah. Question? Yeah. What do we mean by hard tokens? So sometimes FIDO2 tokens. So sometimes we see that we need to connect to external partners which are not belonging to our organization, and we need to distribute these tokens and integrate their identity management system with our identity management system, which means federation, which means a bit more complex control plane. Yep. Thank you. So in the next slide, you can see the control plane and why does it matter. I just started to say and reason why does the control plane matter. So we would like to be compliant with a lot of security audits and security regulations from ISO 27001, GDPR, and many others. On the other hand, we would like to limit the security risk because of our interest, our own interest, not because of other audit requirements, because of our own interest. So we developed a 7-zone control plane that I will show you in the next slide that can... I have a question. When it makes sense to have it on-premise versus on-cloud? Yeah, so the question is, when does it make sense to run this whole environment in the cloud or on-prem? We see many times that the customers want agentic workflows. The agentic workflow will produce a lot of tokens, a huge amount of tokens when it's thinking. And we see also increased pricing both on cloud, Claude and on ChatGPT as well. Previously, we told the customer that there are security and financial reasons. We say that there are financial reasons and security reasons. So it's more and more relevant, the financial reasons, while we are talking about agents and that verbosity that the agents produce. So we see more and more requests from the customers, and even a small-scale solution can run on an RTX 6000, which is relatively cheap, and scaling up to multiple RTX 6000 GPUs. So we see more and more relevance on the on-prem solutions. Yep. So going back to this, if I want to protect my environment, then I need a very good scalable control plane and a secure control plane, for which we developed this 7-zone control plane in order to make that happen. Just to have a frightening fact, we have 24 nodes in that. I understand that this is not a minimum for a small enterprise where they want to run everything on one cluster, but for larger enterprises and especially CSP providers, for us the 24 nodes is a kind of a minimum, because we want to segregate each and every security zone. And here is the control plane that we introduce at these higher security requirement customers. And even these zones, as I mentioned, can be unified and collapsed into a single cluster with, let's say, 7 nodes as a minimum. However, our suggestion, again, to separate them onto separate clusters. So these are separate virtualization clusters, edge/DMZ, where the customer would come in, shared services with DDI. So the DNS, DHCP, IP address management, very important. IP address management is important because if you have an operation with a quick change, I mean the whole environment is fluctuating because you repurpose everything many times, you have a lot of containers, you have a lot of virtual machines maybe, then it needs a lot of IP addresses, and when the customer requests IP address, gives back, requests, gives back, then the IP address range will be fragmented. So something has to take attention to and pay attention to the IP address changes, and the DDI system is the one which makes the IP fragmentation less system. Bastion host, NTP server, really important if you want to make an enterprise-grade or CSP-grade solution. Even the cesium-based atomic clocks are eligible, so it's important. Identity and security management, including the federated identity management, password management, directory, automated directory. So many times we see that the customer have either LDAP or Active Directory, and still we say that, okay, you can have your existing environment, that's good, really good. However, because of the business schedule, we would like to introduce this control plane, have it ready, put it into your environment, get the GPUs into operation, and then you can integrate it with your existing systems. However, you will lose much more money. You will lose much more money on the GPU sitting idle than buying that as an extra cost. Or if you are brave, then we can say that, okay, we can use the Active Directory. However, the integration time may be long. We will see. Our main idea is to deploy this, install this as an island, and later we can integrate to the on-prem existing systems. I mean, this is also on-prem, but I just want to say that we are integrating later to the AD or whatever. Management and orchestration, this is about the monitoring and about the non-IT management. So the non-IT management, or OT, is very important as well when we want to monitor the leakage, when we want to monitor all the fans are working in the chillers, all the buffer tanks are in operational state, all the valves and etc. So the non-IT management will be important. Observability. So at day one, everything is green. However, on day 2 or later, you will experience some orange exclamation marks. So we will need to know what does ruining the system. We need an observability or monitoring system, and we want to make a CM system as well. In our system or in our concept or solution, we can do it either with open tools or with, for example, with the help of Elastic friends there. So if you want to make a good system, please talk to the Elastic guys, because they do a lot of good things in this space. Also, by the way, in the edge/DMZ, so here, when we need to implement firewalls, I don't want to forget the Fortinet guys and Palo Alto guys, because they are doing a lot of good high-end systems. So we also integrate their firewalls, their WAF solutions, their protections or CyberArk in the password management into the security. Regarding, I will come back to this a bit later, regarding bare metal management and bare metal provisioning, just keep in mind that from time to time you need to reprovision your GPU nodes, you need to upgrade, and this is not an enterprise solution. I mean, it can be, but I suggest not to handle as an enterprise solution. In the enterprise lifecycle, we always upgrade the operating system on the spot, I mean, on the actual node, and we assume that there will be a proper backup and everything. In the GPU as a service space, we just drop the image and we deploy a new image. Drop the container, deploy a new container. So that's the upgrade process. We can do the traditional enterprise lifecycle, however, that will be a bit more harder for your maintenance and operation. Tenant compute control plane. When we want to actually operate the GPU nodes, so we want to run some Kubernetes, because Kubernetes is the most relevant on GPU nodes, then we want to run some management nodes, and these management nodes run in the tenant compute control plane. Sometimes we see that the departments want to have their own management plane. So just imagine that we have 6 GPU nodes, and we have security zone 1 and security zone 2. Those 2 security zones cannot run on the same control plane. A single control plane consists of 3 hosts. So even in this small environment, we need 6 management nodes just to manage the 6 worker nodes, 6 GPU nodes. I understand this is not an everyday case. However, we see at larger customers where they have multiple hundreds of nodes that they want to dedicate specific management nodes to specific tenants. Even when you want to invite external partners, for example, you want to invite Novartis and Richter to work on the same cluster, I mean to cooperate with you on their projects, their audit requirements may say that you cannot run on the same shared control plane as your competitor. So you need to dedicate 3 hosts for these purposes. So the tenant control plane may not be a heavy loaded cluster, however, they need a lot of machines. Regarding the standards, we have standards around the liquid cooling and piping on the white space and the fiber copper cabling and the structures, for example, grounding. Why is it important? Because we see many times that the replication of the good and best practices is much, much faster and much better than reinventing the wheel each and every time. So I suggest to reach out to the Dell counterparts if you want to know more about these standards, because they can help your life. Many times we cooperate with the data center providers, for example, on the liquid cooling and power, because we help them to create the data center, actually to how to make the piping, how to make the bus bar systems, and so on and so forth, because we have more experience in that. By the way, on the top right corner, you can see the impact factor. So this software ecosystem with NVIDIA, NIM, and others can help in 8 areas out of the 9 that I enlisted there. So When we are talking about the software ecosystem, we cannot go along, we cannot go without of the NVIDIA software engines, and one of them, one of the most relevant is the NIM. This is a microservice-based, container-based system, which can be very fast deployed onto the existing environments, NVIDIA environments. It can be agent-based as well, and it can cooperate with the whole stack, including the storage and the whole orchestration engine. In order to make the whole environment fast, we are introducing a system which is called Lightning. The Lightning is a software-defined storage solution for those customers who require a lot of bandwidth. So you can see there somewhere, maybe on the next slide, that it can provide 6 terabyte per sec per rack, terabyte per sec per rack. So when you are thinking about what storage solution should be there at the GPU system, just bear in mind that currently one Rubin GPU can load the data with 8 gigabyte per sec per GPU, 8 gigabyte per sec per GPU per operation. So when you have 8 GPUs, that's 64 gigabyte per sec, and not gigabit, gigabyte per sec per node, if you want to feed with data. So Lightning is one of the fastest platform out there that I would suggest. If you cannot decide which way to go, then we are happy to introduce this software-defined storage for the larger customers, in which we can repurpose the storage either into the Lightning or to an object scale, as the name suggests, it's an object storage, or to a power scale, let's say traditional power scale, which is the next generation one, so it's also a fast one. In generic, for smaller customers, we suggest using power scale because it's fast. It can do object, NFS, and policies, so it's really flexible. You can build a very good namespace. It has Kubernetes connectors as well, so it's really easy to integrate. It has security features and many things that is required. NCP compliant if you want an NCP compliant solution. So it's really good. However, if you want to grow larger, then this software-defined approach can be a good solution. Another topic to talk about is the Vera Rubin NVL72. So we are talking about the rack scale solution. It has a high bandwidth domain in the back, so the NVLink is very fast, so it behaves as one large cluster of 72 GPUs. Yeah. Can it contain that solution? Here in this, multiple tens of petabytes, so 100 petabyte is not an issue. And it's mainly flash-based. Yeah. So regarding the NVL72, it behaves as one 72 GPU node. So if you want to run distributed inferencing or distributed training, then this can be the right platform for you. If you want to go a bit smaller, then we are introducing continuously new platform with new generation GPUs. So for example, RTX 4500 can be put into this R770 or 7725, so the AMD counterparts, either one CPU or two CPU versions. If you want to go to an 8 GPU system, so NVL8 here means 8 GPU system, then the newest configuration is 2 OU or 2 rack unit, because we are talking about Rubin. So it's 2 RU high with 8 GPUs. Just imagine that you are not now seeing 25 kilowatt power consumption in 2 units. So if you imagine that we can put, let's say, 18 into a rack, how much power consumption would it mean? So it's around 400-ish kilowatt per rack. That's something. We cannot cool it with air. So in the next generations, we see that the air-cooled will not be present for the high end. Only the liquid-cooled design will be present. So if you want to buy an 8th GPU system, then liquid cooling will be mandatory. In theory, even in theory, we cannot cool out 25 kilowatt. I mean, that would require 20 unit heatsink or something like that. So it's insane. Okay, the next ones are the Vera platform. So NVIDIA Vera CPU, the ARM CPUs, will go into the Dell servers. So we will sell Dell servers with ARM CPUs, not only x86, but also ARM. Yeah, please. Yeah, so regarding the rack size, we are not selling too much 42-inch anymore, so 48 and 52U racks are relevant now. Yeah. Please. Yeah. Yeah. Yeah, so the question is, if the current solution runs on Amazon, how easy is to repatriate it and migrate it back? We have software engineers who can help in this. Sometimes we need some code rewritten because we cannot make 100% that environment, but we have a cloud-based solution which is called Dell Automation Platform. My last slides are about that Dell Automation Platform. It will provide you a cloud-like infrastructure on-prem. Yeah. So ARM CPUs in Dell servers, and we also have high-density solutions as well. Regarding the switches, we introduced the NVIDIA Spectrum 6 switches. Those are 1.6 terabit per port. 1.6 terabit per port. That's something. We are expecting this at the end of the year, and we will have other form factor switches as well. And this is the high-end InfiniBand switch, which is also high throughput and high radix switch. New thing that NVIDIA switches will run sonic distribution, so that means that the complete environment, including the Dell switches and the NVIDIA switches, will be able to manage using the sonic solution. And this is my last two slides about the Dell Automation Platform and the modular architecture, in which you see that we have a modular foundation with the server, with the switches, with the storages, PowerScale storages. And on top of that, we are building out the operating environment either for enterprise, smaller scale, using the Dell Automation Platform, or for larger environments using these control plane that I showed to you previously. So the Dell Automation Platform is the one which is building on top of that. Currently, we are integrating with Cohere. Cohere North is a really good environment for agentic workflows. I showed yesterday a wealth management system based on Cohere. We also have Data Robot, ClearML. ClearML is one of the best providers that we use, and we sell them many times, the ClearML Enterprise, because it can give you a very good and flexible software environment. And Aible is an IT help desk solution with automated AI-based helps. Okay, that was my last slide. Just another question. Yep. Yeah. So regarding the backup, it's a nasty question. So the control plane backup is clearly the data domain and the PPDM that we have. That's the control plane. Regarding the worker nodes and the GPU backup, you either use PPDM or you can use some external vendors. We have the PowerScale A series, so the archive nodes. Those are very price-effective backup targets. Providing S3, I encourage you to visit that and use the A nodes for backup targets, because we are talking about multiple petabytes of data. Yeah. Thank you. Thank you, guys.